ChatGPT, machine learning, AI agents. I mean, these terms are everywhere, right? It feels like every single company is launching some new AI feature. But what do these buzzwords actually mean? And more importantly, how do they all fit together? It can get confusing and fast. So in this explainer, we're going to demystify it all. Let's dive in. The best way to think about all these concepts is kind of like a set of those Russian nesting dolls, where each idea fits inside a larger one. We're going to use this diagram from Carnegie Mellon University as our map for today. You see that big outer ring? That's artificial intelligence. It's the big picture, the field that contains everything else. We're going to unpack these layers one by one. So here's our game plan. We'll start by mapping out this AI universe. Then we'll get into the weeds of machine versus deep learning. From there, we'll jump into the generative AI revolution, look at what's next with smarter AI workflows, and then wrap it all up with the key takeaways for you. All right, first up, mapping the AI universe. It's really important to start with the broadest categories so you can see how everything else connects back to it. So at the very, very top, we have artificial intelligence, or AI. This is the big one. It's the all-encompassing field. You can think of it as the parent category for any tech where we're trying to get a computer to do something smart, something that would normally take a human brain to figure out. It is the whole universe we're exploring today. Okay, let's move on to our next section and see how this all builds. We're about to zoom in one level from the huge idea of AI to look at the two powerful engines that really make most of modern AI possible: machine learning and deep learning. And if we look at our map again, you can see machine learning is a huge field inside of AI. And then, nestled right inside that, is its powerful, more specialized subset, deep learning. This relationship right here is absolutely key to understanding how AI has evolved so quickly. So, machine learning, or ML, this is where things start to get really cool. Instead of a programmer writing out explicit, step-by-step instructions for a computer, you just give it a ton of data and let it figure out the patterns for itself. Now, it tends to work best with structured data. Think of neat rows and columns in a spreadsheet. And a human expert often still needs to give it a little nudge by selecting which features or which columns of data are the most important ones to look at. This is a perfect illustration of a core ML technique called supervised learning. Just imagine feeding a system thousands of examples of houses that have already sold, right? You give it their size and their final sale price. The algorithm just chugs through all that data and learns the relationship between size and price, which is what that blue line represents. Then you can give it the size of a new house, and boom, it can predict the price. It learned the pattern all on its own. Now, let's talk about deep learning. This is a subset of machine learning, but it's basically supercharged. It uses these really complex structures called neural networks, which are loosely inspired by the human brain. The deep part just means it has many, many layers in these networks. And that's what allows it to tackle massive, messy, unstructured data. We're talking photos, audio, raw text. And this is crucial. It can learn which features are important all by itself. No human guidance needed there. Okay, so this is where you can see the practical differences really clearly. Look at the row for feature extraction. With ML, an expert has to manually pick what's important. With deep learning, it's automatic. That one difference, that's the game changer that unlocked all of modern AI, making things like large-scale image and speech recognition possible. But it comes at a cost. DL needs way more data and much more powerful hardware. And here's the most fascinating trade-off: interpretability. ML models are often easy to understand, while DL can be a total black box. We know it works, but it can be really hard to know exactly why it made a certain decision. And all of this brings us to the technology that's completely reshaped the world in just the last couple of years: generative AI. Now, this isn't some totally separate field, but it's a really powerful application of deep learning. This is how AI learned not just to recognize patterns, but to create brand new stuff from scratch. It might seem like absolute magic, but the fundamental idea behind large language models like ChatGPT is stunningly simple. Seriously, when you strip away all the complexity, their main job is to do one thing over and over and over again: predict the most likely next word or token in a sequence. That's it. Let's actually see it in action. So if you give the model the text "Mary had a," it analyzes all the text it's ever been trained on, which is a huge amount, and it calculates the probability for every possible word that could come next. In this case, it figures out that the word little has the highest probability at 40%. And here is the really clever part. The model then just adds that word to the text, creating "Mary had a little." Then it does the exact same thing again. It feeds this new, slightly longer phrase back into itself and predicts the next most likely word, which is lamb. By just repeating this simple, almost primitive step thousands of times, it builds coherent sentences, paragraphs, and even entire essays. So, if generative AI is just a brilliant text predictor, what's next? I mean, as impressive as it is, simple prediction isn't really enough for complex multi step problems. The answer lies in moving from just generating stuff to actually solving problems. And this is the big shift towards smarter AI, using what are called agentic workflows. To really get this leap, we have to understand the limitation of the current method. The AI pioneer, Dr. Andrew Ng, uses this fantastic analogy. Giving a standard prompt to a large language model is like telling someone to write a perfect essay in one single go, from the first word to the very last, with no planning, no drafts, and no backspace key. It's frankly amazing that it works at all, but that's not how humans solve complex problems, is it? And here you can see the contrast perfectly. The old way, what we call zero-shot prompting, is a straight line. You give one prompt, you get one final output. That's it. But agentic workflows introduce a loop. You give one prompt, and the AI system creates a plan, generates a piece of the solution, tests that solution, and then revises it. And it repeats the cycle over and over until it has a polished final output. It's a much more iterative and, frankly, a much more human-like process. A great example of this in the wild is Landing AI's Vision Agent. It's not one single AI. You should think of it more like a team of specialized AIs. First, a planner agent breaks a complex request down into smaller steps. Then, a code agent actually writes the code to get those steps done. And finally, and this is the magic part, a test agent runs that code, checks it for errors, and sends feedback back to the code agent to make corrections. It's this continuous loop of planning, doing, and checking. So, wow. We've journeyed from the broadest concept of AI all the way to the absolute cutting edge. Let's take a second to summarize what this evolution from simple prediction to complex planning really means for all of us. So let's recap this whole hierarchy, our nesting dolls. AI is the entire universe. Inside that, you have machine learning, which learns from data. Deep learning is a powerful subset of ML that's great for complex patterns. Generative AI uses that deep learning to predict the next step and create new things. And finally, AI agents layer an iterative, problem-solving workflow on top of all of it. And that leaves us with a pretty fascinating question for the future, doesn't it? We've just seen AI evolve from a one-shot content generator into a multi-step, iterative problem solver. So what becomes possible when an AI system can be tasked not just to write an essay, but to autonomously handle the entire workflow, to research the topic, create an outline, draft the content, and then edit it for clarity and accuracy? The possibilities are truly transformative.